Hello everyone, welcome back, and let's talk about the objectives one last time. So the two objectives are to learn IPv6 unicast addresses, and we also want to have this PC be able to reach this web server. All right. Now, in the previous videos, we talked about IPv6 link local addresses, and we also talked about unique local unicast addresses. All right. Today, and right now, we're going to talk about global unicast addresses. Now, to do this, we need to role play again. And as a result, I've altered the topology or depiction to help us understand global unicast addresses a little bit better. Now, again, in the previous video, because we were dealing with private addressing, meaning that all the IPv6 addresses were contained within one autonomous system, one collective routing domain. Now, what is an autonomous system? Again, very important. An autonomous system is a collection of network devices. It can be either routers, switches, or even firewalls that collectively work together as a team to build one system. They work together to reach a consensus on how to route traffic and how to deal with a disaster and recover from it. The network devices collectively work together in an autonomous fashion. Now, why is this important? Because an autonomous system represents an entire infrastructure of an organization, enterprise, or even can be a service provider. An autonomous system is not limited to anything. It's just a team of network devices that represent an organization's routing domain. Now, there's going to be a time in which the autonomous system you're managing needs to reach other services outside its local routing domain. Or maybe the autonomous system you're managing is actually hosting a service that requires to be accessible to people outside of your organization. So what do? Well, we connect to other autonomous systems. That's what we do. Or maybe autonomous systems we're managing, maybe the autonomous system we're managing is selling a service and your clients need to connect their autonomous system to yours. And hence, that is what we've just described as the internet. The internet is the interconnection of autonomous systems. Okay? The internet is not owned by anyone because it's just the interconnection of autonomous systems, and the only eligible address space that is allowed to pass between autonomous systems are global. So public IPv4 addresses or public IPv6 addresses. The autonomous systems will not accept addresses that are public. Usually, in best practice, they'll have filters on the edge of their routers to accept only the public IP addresses that were negotiated at the table. Okay? So, as you can see, I modified the topology a little bit, but not that much. Because the only thing I had to do was I had to change this link to be a public, and I had to change this link to be a public. Because we're not simulating a situation in which a employee is reaching a local web server. We're simulating a situation in which a client, a public user, wants to reach a service you're hosting. Very different. So to do this, I had to configure this link as a public link, this link as a public link, and this link as a public link. However, one key important point to understand is that the only way that you can actually interconnect autonomous systems together, or the most practical and best way, is by using a protocol called eBGP. And that's what I've configured here. So I want to show you my configuration. Okay? So very simple. On Acme Edge, as you can see, I've configured the interface to be a public interface. Hence the IP version prefix 2001. And then I have the router's BGP. So we start off with its own autonomous system. It's neighboring on the interface that is directly connected to this one and referencing the neighbor's autonomous system as the remote AS. And I'm also advertising out via the IPv6 address family under BGP this subnet. And I'm doing the same thing in reverse on the other side. Okay? So what I'd like to do is just apply the configuration and then do the testing. But if you'd like to try this at home, I'm just going to share my configuration on this side as well. So there you go. Oh, here it's IPv6 auto if you'd like to do it at home. Okay. All right, I'll be right back. All right, everyone. So I just applied the configuration, and now we're just going to have some fun. So on the Acme Edge router, which is this gentleman right here, I'm going to do the show IP BGP all summary command. And as you can see, I'm receiving one prefix. You can issue this command on the other edge to do the exact same thing. All right. If we do IPGP all, it'll show you the prefixes that you're receiving from your neighbor. So as you can see, I'm receiving from the ABC company the subnet or the IP address 2001 subnet 4. And which one is subnet 4? It's this guy right here. So the ABC Edge 2 is announcing subnet 4, and Acme Edge 1 is announcing to ABC subnet, I believe it's 1. Actually, why don't we just take a look at that? So it'll show IPBGP all. Oh, show IPBGP all. And there you go. Okay, now let's go ahead and do some testing. So this gentleman's IP is show. All right, so we're just going to grab that, copy, go to PC1, and there you go. We have connectivity. And that, I hope, was useful. Take care.